This is our team and our project, and here's Austin.
So the first thing that we had to do was we had to find our parameters for this circuit, and we were calculating for our on time, our off time, our period, and our duty cycle, along with our average voltage. Once we found our on time, which came out to 5.89 milliseconds, I then calculated the period, which was, assuming in this case we're using a 70% duty cycle. I took our on time and divided it by the duty cycle, which gave us a period of 8.41 milliseconds. And then at that time, to get our off, you take your period minus your on time to get 2.52 milliseconds. And then down here, to get our average, taking into account the 100 ohm resistor, which was required in this practical, a 1.7 voltage drop across the LED, and assuming our 15 volt voltage supply, doing your duty cycle times your supply will give you your average, which in our case comes out to 9.31 volts.
Here's Richard.
Rick's going to describe the build here. So we'll get a diagram of the build. We got 555 timer. Power is going into 5 volts going to here. We're also coming around to the reset and the discharge side through this is R1 here. Then we have R2. This is the pot R3 around for the capacitor. We got our 2 diodes for rectifying. This is R4, R5, the Darlington pair. We did set the pot at what our simulation put at 7.5 and 2.5, and we got our on and off cycles were a little longer than the simulation, and next will be Marcus explaining why.
All right, Marcus here. So So using our oscope, we found that our period ended up being 11.2. So we have 7.6 milliseconds for our high and 3.6 milliseconds for our low. As Rich mentioned, we had our pot set the same way that we did on the simulation, and we believe it's an issue caused by the cap, because it's not going to run the same for every single one as they do in the simulation. We verified our power, we verified it through the multimeter, and then through our oscope.
We can do the resistance across the pot. What's that for? There we go. We're just shy of the 7.5K that the simulation said.
But still, our period would have is the same regardless. So we check this, and that's our Darlington pair. Thanks.